Epicyclic gear train, right? Algebraic method. Okay, right. So this is a kind of direct application of this relative velocity. Yeah. So you need to have like little bit of concentration on the relative velocity. We'll see. This algebraic method, the motion of each element of the epicyclic train relative to the arm is set down in the form of equation. So each element, A is an element, B is an element, and arm is an element. So each element we are going to set down in the form of equations. The number of equations depends upon the number of elements in the gear train. Right? Let the arm C be fixed in an epicyclic gear train as shown in the figure. So now we are going to do as like what we have done in the tabular method. Now we are going to fix the arm C, right? So now only A and B are going to move. Therefore, speed of the gear A relative to the arm C, right? Speed of gear A relative to arm C, which means we are going to stop C and only A is going to move. So if you remember the relative velocity, right? If this is the velocity of A, right? And if this is the velocity of C, in order to find the velocity of A with respect to C, what do? We apply an opposite same velocity to C and to A, right? So opposite same velocity to C means now C is going to be 0, right? If C has a velocity this way and applying same velocity C this way, the velocity of C is going to be 0. So here also I will apply the same C to this A. So now A has a velocity VA this way, right? And velocity C is acting on the opposite direction. So that will be subtracted. So at the end, what will I have? VA minus VC. So relative velocity of A with respect to C will be given by VA minus VC, right? This you already know. So same formula or idea we are going to apply here also, right? Speed of the gear A relative to arm C, right? So which means I'm going to stop the arm and I'm going to leave the A to move. So that is BAC. Here I have NAC relative to arm C. What's the moment of A? That is NA minus NC. You see here VA minus VC. Similarly, speed of A minus speed of arm, right? So this is the speed of gear A relative to arm C, right? You need to look carefully into the sentence. This is relative to C. So which means you are stopping the C and allowing the A to move, right? Then again, speed of the gear B relative to arm C, right? So now this B relative to arm C, right? So that is NB minus NC, right? Velocity of B minus arm. Since this is relative velocity, that is NB minus NC, right? So this is the speed of gear B relative to arm C. So now I have found speed of gear A relative to arm B, arm C, and speed of gear B, B relative to arm C. All right. So I have two equations now. Now we will put them over here in the equation. Since the gears A and B are meshing directly, therefore they will revolve in opposite directions, right? So you see here, they are meshing directly. So if A rotates this way, anti-clockwise, you know B will rotate in the clockwise, right? That is obvious. Since this is making a kind of form of a simple gear train, if this is moving clockwise, definitely this will move in anti-clockwise, right? This we know. So since the gears A and B are meshing directly, therefore they will revolve in opposite directions, right? B and G are going to rotate in the opposite directions. Speed ratio we know can be given by NB upon NA is equal to TA upon TB, right? So if I apply this equation and this equation in the speed ratio equation, that is NB upon NC upon NA upon NC, NA minus NC, sorry, NB minus NC upon NA minus NC is equal to TA upon TB, right? Why? It is given the C is fixed, right? Let the arm C be fixed. So if the C is fixed, I can put 0 for C, right? There is no speed for C. So instead of C, I can put 0 here. Here also I can put 0. So that is NB minus NC, that is 0, upon NA minus NC, that is equal to 0. So NB minus 0 upon NA minus 0, that is equal to NB upon NA, right? That is NB upon NA will be equal to TA upon TB, TA upon TB. So this we know, this is our usual speed ratio equation, right? NB upon NA is equal to TA upon TB. This is our normal speed ratio equation. If the gear A is fixed, then NA is equal to 0. Now we are going to fix NA, right? NA. NC is already fixed, right? Now we are going to fix NA also. So if I fix NA here, this NA is going to be 0, right? But here now we are not talking about NC is fixed. Okay. If NC is fixed, then this is a condition. So this is the standard formula, right? NB minus NC upon NA minus NC equal to TA upon TB. If I fix NC, right? If I fix the arm, I will put 0 here to NC. And the equation will become NB upon NA is equal to TA upon TB. Right? If I leave the C to move and if I fix only A to 0, what will I do? I will put A is equal to 0 here, right? A is equal to 0 here, but C, that will move right now because C, I did not say that is fixed. So when this A is fixed and C is moving, this equation is going to come like this. NB minus NC, that will be like this. NA, I said now, is fixed, right? NA is fixed. So it means NA, here it was NA, now it is fixed, that is 0. Okay, so NA is fixed, that is 0. So this equation will reduce to NB minus NC upon 0 minus NC. Why? NA is equal to 0. 0 minus NC is equal to minus TA upon TB, right? TA upon TB. So this you can solve like NB upon NC. Here NC upon NC, that is 1, right? So NB upon NC is equal to 1 plus TA by TB, right? You can make NB by NC as the subject, right? So here I will have minus NB upon NC. If I take it this side, I will have NB upon NC. Here I have TA upon TB. I will take it here. So TA upon TB plus 1, right? So 1 plus TA upon TB. So if NA is fixed, then this is going to be the equation. If NC is fixed, then this is going to be the equation. Say for example, you fix the NB, right? If you fix the NB, then NB will be equal to 0, right? So in that case, what will happen? Instead of NB, I will put 0. NC would be like that, and minus NC. Then at the bottom, I have NA minus NC. So there is no change on that, right? Only NA is fixed for NA minus NC equal to, this will be TA by TB. That will be fine, right? TA by TB, that will be like that. So from this, you can have NA minus NC by, and this way TB, right? And then if you solve, so I will take TB upon TA equal to, right? I'm taking it upside down. NA minus NC upon minus NC, right? So here TB upon TA is equal to minus NA upon NC plus 1, right? So you can have 1 minus NA upon NC equal to TB by TA, right? TB by TA. So minus NC upon minus NC, that is 1. NA upon minus NC, NA upon minus NC. So 1 minus NA by NC is equal to TB upon TA. So this will be the equation when B is fixed, right? So when B is fixed, right? So this is the equation when C is fixed. This is the equation when A is fixed, right? So this is your base equation, and from this you can fix whatever the link you wish, and you can move to the numerical, right? So NB minus NC upon NA minus NC is equal to TA upon TB, and this is the base equation. And this is how we do the algebraic method, right? An epicyclic gear train, an arm carries two gears A and B, right? So epicyclic gear train arm carries two gears A and B, having 36 and 45 teeth respectively. So A has 36 and B has 45 teeth respectively. If the arm rotates at 150 rpm, so if the arm rotates at 150 rpm in the anti-clockwise direction, so this is going to move this way about the center of the gear A, which is fixed. So now the gear A is fixed. Okay. Determine the speed of gear B. So under these conditions, you need to find the speed of the gear B. If the gear A, instead of being fixed, makes 300 rpm in the clockwise direction, what will be the speed of gear B? So there are two questions actually. One, if the A is fixed, what will be the velocity of B? I mean speed of B. Second question, if the A is also rotating with 300 rpm in the clockwise direction, what will be the velocity of B? Right. So now we'll fix the given data. Right. TA, that is 36. So number of teeth on A is 36. TB is 45. Number of teeth on gear B is 45. NC is 150 rpm. So rotation of link C is 150 rpm, and that is anti-clockwise. So now this link is going to rotate like this. Okay, and this is fixed. A is fixed, so NA is going to be fixed. Question asked is, when this is fixed, what would be the speed of B? Second question, when this is moving with 300 rpm in the anti-clockwise direction, what would be the speed of B? Right. So this is a question. We'll now see how to solve this. So again, we'll put NA speed of gear A, NB speed of gear B, NC speed of arm C. Okay, assuming the arm C to be fixed, right? We'll assume it. Speed of gear A relative to arm C is equal to NA minus NC. We already know, right? If we are fixing C, and if the gear A is respective to gear B, then the speed is given by NA minus NC. And speed of gear B relative to arm C is equal to NB minus NC, right? Since we are assuming the arm C is fixed, right? Assuming it. All right. Since the gears A and B revolve in opposite directions, right? So we know, since they are acting as a kind of simple gears, they are going to rotate in the opposite direction. So if A is rotating this way, the B is going to rotate this way, right? So we can use the formula. What is our formula saying? NB minus NC upon NA minus NC is equal to minus TA upon TB, right? So that's the formula, right? That's the formula, right? Here's the formula, right? NB minus NC upon NA minus NC equal to minus TA upon TB. This is a formula, right? So I will apply in the formula. Speed of gear B when gear A is fixed. So now this is a standard formula. Now we are going to fix whatever we need. When gear A is fixed, so which means NA is now going to be 0, and the arm rotates at 150 rpm, and now NC is going to be 150, right, in the anti-clockwise direction. So anti-clockwise means now I am taking anti-clockwise as positive, right? There is no any standard whether you have to take anti-clockwise positive or you have to take anti-clockwise negative, nothing like that. But whatever you are taking, you need to keep it up. You have to keep it up throughout the numerical, right? So now I am taking anti-clockwise as positive. So in this equation, I am going to substitute NA and NC, because NB I have to find. NB, I don't know, I have to find. NC minus 150, this minus is already there, 150 upon NA. NA is 0 because it is fixed, minus 150, right? 150 equal to minus TA upon TB, right? Equal to minus TA 36 upon TB 45, right? So 36 by 45, we know that is equal to minus 0.8. Okay, When you solve it, NB minus 150 is equal to 150 into 0.8. So that will be minus will be cancelled. 150 into 0.8, 120, right? So NB minus 150 is equal to 120. NB is equal to 150 plus 120, that will be equal to 270 RPM, right? 270 RPM. So this is for the condition of B is moving, I mean A is empty. Okay, this is for A is fixed, right? So same equation, we are going to fix whatever we wish, and we are going to apply numbers whatever we know, right? Next one, speed of gear B when gear A makes 300 RPM clockwise, right? So here we have to find the speed of gear B when the A is making a 300 RPM clockwise motion, right? So again, we will replace in this equation NB, which I have to find, minus NC it's 150, right? 150 upon NA. NA it's given in the question that is rotating clockwise, right? But we take anti-clockwise as positive, right? Anti-clockwise as positive. So if it is clockwise, then I have to put negative. So instead of NA, I will put minus 300 minus NC 150. Okay. So NB minus 150 is equal to minus 300 minus 150, that is minus 450, equal to minus 36 by 45. Okay. 36 by 45 is equal to minus 0.8. Right? Minus 36 by minus this 45 is equal to 0.8. Minus 300 minus 450, that is minus 450. So NB minus 150 is equal to minus 0.8 into minus 450. So minus 450 into minus 0.8 is equal to 360. Okay. So NB minus 150 is equal to 360. And therefore NB is equal to 360 plus 150, that is equal to 510, right? So if I can write, I will write it as NB minus 150 is equal to minus 300 minus 150, that is minus 450 into minus 0.8, right? Minus 0.8, that is this 0.8. So which is equal to minus 450 into minus 0.8 minus into minus plus 450 into 0.8 equal to 360, right? So NB is equal to 360 plus 150, right? This minus 150 will come this way, so will be added 150. So I will have 510 RPM. Okay, 510 RPM. So motion of, I mean speed of B when gear A makes 300 RPM clockwise is equal to 510 RPM anti-clockwise. You need to say the direction also, right? Since the answer is in plus, that is anti-clockwise 510 RPM. Okay. So this is how we solve the numerical in the algebraic method.